I want to talk about how to graph the tangent functions. We're just going to talk about the parent function y equals tangent x. And one of the things I'm going to start with here is I'm going to start with a unit circle. So I'm drawing with my little unit circle. And I put in all my points and I put in their coordinates so that you can see them. It's also really important to remember that tangent theta is equal to sine theta divided by cosine theta. We know we cannot divide by 0. It is impossible to divide by 0. That is undefined. So what I need to look at in my unit circle, in order to graph the graph of tangent, I want to find, first of all, every place that cosine theta is equal to 0. Because where cosine theta is equal to 0, it is undefined, and I'm going to have an asymptote. So, at 0, 0, well, I'll write on the board here. At 0, 0, at my angle 0, cosine is equal to 1, and sine is equal to 0. So that's equal to 0, and there's nothing wrong with that. But as I move up the circle here, and I get closer to pi over 2, my sine becomes 1, not negative sign, and my cosine becomes 0, and that is undefined. So at pi over 2, I'm going to have my first undefined point. So I'm going to make my graph here, and I'm going to say that this is 2 pi, and halfway to the 0 is at pi, and then I'm going to go negative pi, and I'm going to go negative 2 pi. So this is going to be negative pi over 2, and this is going to be negative 3 pi over 2, and this is going to be pi over 2, and this is going to be positive 3 pi over 2. And I'm just pointing out, I'm making essentially a number line here, but instead of making that number line with integers 1, 2, 3, 4, 5, I'm making it with values of pi, and there's nothing wrong with that. I can determine my own scale. So at pi over 2, I am going to have an asymptote. And if I keep going around the circle, I can see cosine is going to be equal to 0, again, at 3 pi over 2. So I'm going to have an asymptote there as well. And if I went negative around the circle, I would have an asymptote here at negative pi over 2, and I'd have an asymptote there at negative 3 pi over 2. So here's negative pi over 2. I'm going to have an asymptote. And negative 3 pi over 2, I'm going to have an asymptote. Every place that cosine is going to be equal to 0, I'm going to have an asymptote. And once I get my asymptotes, the graph of tangent pretty much graphs itself. So what's the next step? I've got my asymptotes. Between every two asymptotes, right in the middle, there's going to be a 0. So here's an asymptote here, I have a 0. Asymptote here, I have a 0. Asymptote here, right in the middle there, I have a 0. And let's just check that for a second. So this 0 right here, I'm saying is at pi. Well, at the angle pi, right here, my sine is equal to 0. My cosine is equal to negative 1. 0 divided by negative 1 is 0. I'm okay if sine is equal to 0. I just can't have cosine equal to 0. And sine is equal to 0 at pi. Sine is equal to 0 at the angle 0. Sine is equal to 0 at the angle negative pi. So I've identified my zeros. First the asymptotes, then right in the middle of all the asymptotes, right between each asymptote set, is a 0. Then the next thing I want to do is I want to look at the points that are between my zeros, right between my zeros and my asymptotes. So this right here is the point pi over 4. And we remember that. I drop my perpendicular down. That is halfway between 0 and pi over 2. Between 0 and pi over 2 is a 90-degree angle. So cutting that in half makes this a 45-degree angle. And 45-degree angles on the unit circle have the coordinates in some form or another of radical 2 over 2 and radical 2 over 2. Now sometimes they're positive and sometimes they're negative, but the values are those. And if I divide radical 2 over 2 by radical 2 over 2, I get 1. So it's either going to be a positive 1 or a negative 1. And here's what I do when I'm graphing tangent. I look between my asymptotes, so I'll take these two asymptotes, and I go to my 0, and the point to the right of the 0, between the 0 and the asymptote, is a 1. And the point to the left of the 0, between the 0 and the asymptote, is going to be a negative 1. The point to the right is going to be a positive 1. The point to the left is going to be a negative 1. The point to the right between the 0 and the asymptote is a positive 1. The point to the left between the 0 and the asymptote is a negative 1. And let's just check that for a second here. So this right here is the point pi over 4. That's the angle we just did. The coordinates of that point are radical 2 over 2 and radical 2 over 2. Radical 2 over 2 divided by radical 2 over 2, sine over cosine, is in fact positive 1. But if I go over here to, say, the angle negative pi over 4, I'm going to have the same coordinates of the same distances of radical 2 over 2 and radical 2 over 2, but in this case, my sine, my y value, is negative. So when I divide them, it's going to be negative 1. And sure enough, at negative pi over 4, my point is at negative 1. So I've gotten all these points, I've gotten in my asymptotes. All I need to do is sketch in my tangent graph. And you can see that it just repeats itself over and over again, going through those same kind of points. You can also see that the graph of tangent repeats itself every pi distance, every pi angle, it repeats itself. So the distance between negative pi over 2 and pi over 2 is pi. The distance between pi over 2 and 3 pi over 2 is pi. The distance between negative pi over 2 and negative 3 pi over 2 is pi. Pi is the period of the tangent function.